Hello and welcome to the second lesson of this entire course for an introduction to computers. Now this course is going to give you an understanding of an overview of what makes a computer, different aspects of what essentially comprise to make a computer work, how we humans communicate with computers and so forth as we go along. So this lesson, however, is about memory versus storage. In the previous lesson, we talked about defining a computer. So if you were to explain to someone who has no clue what they are in the 1920s for some reason, then you could do that. Like I said, in this lesson, we will cover memory versus storage. So what even is this? And this sort of relates back to the initial definition that we looked at in the previous lesson, which said that a computer essentially stores and processes data. So we'll sort of look into how this storage works. Now, first of all, there are two types of storing data within a computer, right? The two main different forms of storage is on the screen at the moment. So one is called memory, one is called storage, which can get quite confusing, especially because of the loosely used terms within just the key terms around computers and around technology especially. So you might think, well, they're the same thing. What is the difference between memory and storage? Well, I'll try and break them down into what the technical differences are, what the key sort of characteristics are of either memory and storage in the following slides, and hopefully by the end of this lesson you can understand a slightly better explanation, slightly better understanding of what the differences are. And I'll try and relate this back to how we, the humans, use these two different concepts, because I think that's going to be a good way to relate back to the information that I present in the slides. So first of all, let's talk about memory. Okay, so imagine you wanted to store someone's number in your head. Let's say you don't have any computers or phones with you. If someone told you a number, their telephone number, you had to remember it instantly. And you try and remember it. They say, oh, my number is blah, blah, blah. You remember it. Now, currently, your brain will use the memory part of your entire storage in order to record that telephone number. And the reason is because it's such a short-term storage that you don't need to use long-term memory for it. So memory, in essence, is any information that is used on a short-term basis. Okay, so any information, any data that you're going to need in the next couple of sort of minutes, hours, in one sitting on a computer is essentially stored in memory. And a key term that you might have heard about when discussing about memory is something called a RAM, right? So a random access memory. This is essentially one type of memory, and especially if you're talking about smartphones and the capability of smartphones, the capacity of storage on smartphones, RAM is quite a common term. It gets flown around quite a lot, and if you understand what RAM is on a high level, you know that essentially it's the faster way of storing information. So let's go back to memory. Let's not get too tunneled into what a RAM is. Let's go back to what a memory is for a computer. So we said it's for short-term basis, and typically memory, anything stored in memory, is quite easy to access. So if you store something in memory, it's easy to access, and which means that it's quicker to access that information. All right, so I'll come back to an example of what you might be doing on a computer which requires memory, and that will sort of put everything together. But let's look at the next characteristic of memory, and this is kind of a drawback essentially, because memory, any sort of type of memory, any type of storage which is classified as memory, typically has a very limited storage capacity. So even RAM, when you look at your phone, will have quite a limited capacity. In recent times, you can get up to 16, 32 gigs, maybe even some higher, but typically you'd have something around 8, 12 gigabytes of RAM or memory. So compare that to sort of the storage capacity of things like hard drives and long-term storage. It's quite limited. It's much smaller than the sort of storage capacity. So let's look at the next characteristic, and this is quite an important one. And this is, I would say, the key differentiator between memory and storage, or short-term and long-term storage. And this is something called volatile. So volatility is essentially the idea that if you have some data, right, some information that is stored on your computer, if you turn off the computer, right, say there's a crash, your computer just stops working, turns off, you turn it back on. If the data was stored in memory, you have basically lost the data. You can't get it back. With modern computing and crash recovery systems, you can sometimes get partial data back, and some applications such as Word documents can actually create temporary images of your documents, such that even if something did go wrong, they would have kind of a temporary permanent data stored, and then you could use that to recover. But technically, if something is stored purely just in memory, you can't get it back if the computer or the machine crashes. And this is essentially what's this characteristic is called being volatile. Essentially, it means it's not permanent. And you can get certain memory which is permanent. You can get things which are technically RAM, and they can stay on even after you turn off the computer, but they're very they're used for very specific purposes. So in general purpose computers, you wouldn't talk about those things when speaking about memory. So let's give you an example. Okay, so imagine you're watching a Skillshare or YouTube video on the internet, and your browser has to essentially store information about what you're watching. So even though you can have things like history on your browsers, the actual live retrieval of data for the video is done and is stored on memory, such that you can easily and quickly get the data, view it on the browser, and move on to the next action that you want to do. Similarly, say if you were making a Word document, right? You wanted to make an essay, you were typing in the Word document, you haven't saved it, right? You haven't clicked on save as and blah, blah, blah. It's just on the computer and you're just working on it as you go along. That data will be stored in memory. And there are sort of exceptions to this where, like I said, some programs, especially Word, because they're aware that systems can crash unexpectedly, they've created their own crash recovery sort of subsystems, so you can maybe get away with it. But technically, all of these actions where you haven't manually stored something in your computer for the long term will be on memory. It will be on a short-term basis, but the payoff is it will be quicker and easier to access. So that's memory. Let's move on to storage. And when I say storage, I mean sort of long-term storage, right? So the most common type of storage will be something called HDD, which stands for hard disk drive, or SSD, which stands for solid state drive. So these are used predominantly in computers and PCs and so forth, and they're just two types of storage. But essentially, when I say storage, I mean long-term storing of data. So anything that's going to be on your computer for a long term, and more specifically on a permanent basis, is essentially stored in storage. So the drawback of this is that it's slower to access compared to memory, and because of the way that it's stored, it's more difficult to retrieve, and because of that, it's slower to access. So memory and storage kind of works in opposite. So one thing that's a benefit for memory is essentially a drawback for storage, typically, and vice versa. So storage is slower to access any information, whereas memory is faster, but storage has a very large storing capacity potentially. So something like a hard disk drive will have a lot more storage capacity than something like a RAM, and that's just one of those things that is just set in stone. And modern computers can kind of blur the lines, especially with um, newer sort of advancements where RAM and more specifically memory has become quite large in itself in terms of the storage capacity. You can sort of see a hybrid forming between the two, but we're talking very sort of typical and technical in a very typical and technical sense, where the storage is typically slower and has a much larger capacity to store data. And like memory, storage is non-volatile. So it's the opposite of volatile, which means if you save something in storage and your computer shuts down, you can retrieve it, right? So you've experienced this probably. Like if you were working on a document in Word, you save it, you can retrieve it back when you sort of restart your computer. So that's a fairly straightforward thing to understand. And an example of storage, or two examples of storage, will be essentially archiving some images. So if you're on your image gallery or whatever, and you want to sort of archive some images, you want to store them away, so you can still take them back if you want to, but you don't want them occupying too much capacity, too much storage. You can archive them, and they'll be there for the long term. You can take them back, but it'll be slower to get them back. Another example is having saved documents, like I mentioned, even after turning off the computer. So let's do a quick summary of the differences between memory and storage. Memory, short-term. Storage is long-term. Memory is faster to access the data, and storage is slower to access the data, which means memory is easier to access data, storage is more difficult. Okay, memory has a small storage capacity. Storage has a large storage capacity, and this is all in relation to each other. Okay, memory is volatile, which means if you turn off the computer, the data will be gone. Storage is non-volatile, which means that even after turning the computer off, you turn it back on, you will have the data there if you want to take it back. And finally, something I haven't mentioned yet is that memory is typically much more expensive than storage. Storage is quite cheap relative to memory per sort of gigabyte per unit of storage, which means that because of the expense of memory, you kind of have to use a combination of both memory and storage. Because obviously if you only relied on memory, you wouldn't be able to store a lot of things. But then if you didn't use memory, you would have very long access speeds and very long access waiting times, and it just wouldn't be very efficient. So you kind of need to use both memory and storage, so you can get long-term large capacity of storage, which is non-volatile, but you can also, when you need for some actions, for certain applications, you can use the sort of short-term, faster storage of data. So that's the entire lesson about memory and storage in this Introduction to Computers course. Thank you for watching, and like I said, there are going to be future lessons about input and output, hardware and software, and binary, which is the sort of the big one that you want to be going through if you are interested in how computers and humans can interact with each other. So yeah, thank you for watching, and stay tuned.